Now we're just going to look at the counter and some of its characteristics. And this is the up counter. Remember, there is other types of counters available. And we're just going to maybe look at some of the characteristics again that comes with this that people may not be fully aware of just yet. Okay, so counter is going to count how many times an input is triggered. So that means how many times it comes on and off. Okay, so what I've got here is, again, just using that LED as an output to visualize it, and the start button here on our control panel. So let's go ahead. I press it once. You'll see the output came on and off, and it puts a value of 1 in here. Remember, this is the CV value, the current value of that time of that counter at any moment in time. So what I'm going to do is, if I push it again, you will see it'll get a value of 2 into the counter. So nothing has yet happened. And then again, if I press 3, now I have the LED on. Okay, and that's because the value in our counter has now reached a value of 3. Okay, that's what we're looking for. But notice now that that LED stays on. It stays latched on. So even though we've lost the input here on the left hand side, the output still stays on. Okay, so that's a useful characteristic to note, that the output stays latched on. The counter will keep it latched on. Okay. Now, a couple of things to note before we look at how do we turn off the Q1 LED is, right, we have a value of 3 in here. Well, what happens if I push that start button again? The counter will continue to count. You'll see it's gone up to 6. And even if I did give it, yeah, if we put in another 3, it doesn't change anything to it. So the output just stays on once the value in the counter is greater than the PV, the value that we're looking for. And it will just continue to count, okay? Which doesn't allow for repeatability really at the moment. So it's important that we reset the counter at the correct time. Remember, this output staying latched on. So let's go ahead, we'll press the reset push button and we'll see what happens. Reset. What the reset does, it just puts the value of 0 into the counter. So now the value of the counter is less than that PV value, which ultimately turns off the Q1 error. So we can see that there as we push the start button, 1, 2, 3, Q1 error LED comes on, stays latched on, and then for me to reset it, I need to press the reset push button. Okay. Now, you might just see here that's a wee bit of shorthand from the compiler, which may look maybe a little bit. What you can do is you could extend that out. Listen, sorry, my bad. When you put that in down there, you see that's maybe just what we're more likely to look at. Um, the compiler can just shorthand that down a wee bit, but that's what we're looking at. We're looking at an input there going into a reset part of our counter to reset it. So that's just a couple of things to note, that the counter, once it reaches its max value, or the value that it's looking to get for PV, it will hold the output on even though we lose the input. And that makes sense because the counter is counting how many times the input comes on and off. So it's got to be able to retain information once it loses the input. So that makes sense, and it's different to the timer. So again, look, if we press that and we held it in, it would just be one count. We've got to wait for that to come off and then come back on before we get another count. So it is counting on the rising edge of the input. And then, like we said, once we get a value in our counter that is equal to the PV, the preset value that we're looking for, the error LED or the output will come on. It's not that it's an error, it's just the name of the LED. And that will stay on, it will stay latched on. And then look, if we press the reset, it will turn it off. Okay. Now just maybe this is fairly obvious, but if you had this version, the NOT gate version of the input, the inverted input, wired in, look what happens. Just maybe obvious to know, but it could be worth notice because normally we're seeing that reset button in this sort of a scenario when we're doing latching. But look, that's allowing power to go through the input without the input being pressed. Okay, remember that's different to the start button. It will only allow us to it'll only allow power to go through it when we push it. So the input's not being pressed, it's allowing power to go through, but it's keeping the reset part of the counter high, active. Okay, so now if I press the start button, the counter will not count because it's just constantly being reset. Okay, so just because it's a reset button, and maybe in other examples we've always seen that in the inverted input, note that that's not correct in this state because we only want the reset part to be active when we press it, when we go to reset the counter. So only when we go to press the reset button, then we want the value in the counter to be reset. Now that's a manual reset of a counter, which may not be what you want down the line. You know, if you're counting a sensor, happens 3 times, and then you have to go and manually reset the counter. That's not great. What you will have is you'll have a manual and an automatic setup here. Or really the word I should be saying is an OR. You will have an OR gate here, so you'll have a way to reset it manually, reset the counter if needed, and you'll have a way to reset it automatically. So that may be the output of another, or maybe the value of another output, or another sequence value, or something like that. And we might look at that in other videos, how to reset it automatically. But basically, you'll have a signal, an automatic signal that happens after an event that will allow you to reset the counter. Just note that it can't be, some people fall into a pretty obvious error that once they've started, they'll count up 3 and then they'll try to use that output as an input to itself to reset it. Well, the problem is that you just can't do it because these two things will be happening at the same time, and you'll never see the error LED actually turning on because it'll happen so quickly. But it'll allow you to compile it, but you won't get the proper functionality of the counter working. Okay, you'll want to have something different, some other event that you can measure that can be used as a signal to automatically reset it. And there's a number of ways we can do that, and we'll look at maybe some examples down the line. But a couple of things to note around the counter. This is the up counter. There is other types of counters available, and yeah, it's just some of them small characteristics that maybe aren't too obvious at the start. You just think about a counter, you just think about counting things, but you've got to understand what way the output works after the count has been reached, and the fact that it latches on. Okay.